Hello, I welcome you all to this another interesting screencast. We are going to be solving this engineering mechanics problem, and it reads, determine the force in each member of the truss in terms of the load P and indicate whether the members are in tension or compression. This problem is coming from the engineering mechanics statics textbook, 13th edition by R.C. Hibbeler. Right, let's dive into the problem. Okay, so we have a truss here that is geometrically, or there is symmetry in the geometry of the structure about the BE axis. Okay, the symmetry. But when you look at the loading, it is not symmetrical. Therefore, we are required to tackle each member. Okay, the loading is not symmetrical about this axis. Therefore, we are supposed to solve all the individual members or solve for the internal forces in each individual member. Right. So we're going to do a quick inspection. Okay, we realize that a joint BC or joint C that is formed by member BC and member DC are non-collinear. BC and DC are non-collinear, and we don't have any applied force at point C, and there is no support reaction at point C. Therefore, member BC and member BC and member DC are zero force members. Okay, you could do your calculation by applying the equations of equilibrium at joint C. You still realize that you still be able to find these members to be CB and CD to be zero force members. Okay, so the two are zero force members, so they are as good as not there. So CB and CD are zero force members. Alright, it's important for trusses to do a quick visual inspection to check for zero force members so that your calculation wait time is lessened. Right, now let's draw the free body diagram. The support at A, which is a roller, we are going to have AY, and then the hinge at E, we are having EY and EX. Okay, so let's apply moments about point E. So we have our reference coordinate system, X positive, Y positive, and moment anti-clockwise positive, like so. So summation of moments about point E is equal to 0. What we have negative moment clockwise AY by the lever arm. What's the lever arm? D plus D over 2. This is 3 over 2 or 1.5 D plus P anti-clockwise by how many? What is the lever arm? Is 2D. Right, equal to 0. So 2, no, cannot cancel. So making AY subject to a formula, we'll find that this gives us a 4D divided by 3. Okay, and it's in the same direction, right? So this is 4D divided by 3. So then we have summation. We have summation of moment forces in the y direction, like so, going up in our reference. What we have AY plus EY equal to 0. But we've already calculated what AY is, so we can just replace it there. And when we do so, we realize that our EY is equal to minus 4D divided by 3. And the minus just simply means this arrow is going to change. Okay, instead of pointing up, this is going to point down like so. Okay, so this is equal to 4D divided by 3. Okay, and then now finally summation of forces in the x direction equal to 0. What we have? We have AX, I mean EX minus P equal to 0. And therefore our EX is going to be equal to P. Right, so this is going to be equal to P. Okay. Alright, I guess we are done. We are done for the support reactions. So once we've had this, or once we've calculated this, we can go ahead now to calculate the member forces. So we'll start with joint A. Okay, you can start with any joint, is up to you, doesn't matter. Joint A, what we have? We have a reaction force, which is a 4P, a 4P divided by 3. And then let's assume in here we have a tension force. And looking at the convention, if this is taken up like so, AF, when you look at the way the forces are arranged, you expect a tension in AF. But even if there is no tension, the equations of equilibrium will correct the problem. Then there we expect a compression AB. And then we have this slope here. We didn't calculate the slopes, so let me indicate the slopes. Okay, I can indicate them there. So let D be equal to 1. Okay, because it's going to cancel out later on. So if it is 1, then we expect this distance there at the bottom to be, okay, the distance up there is going to be 1. And then at the bottom there we expect D plus D over 2, so which is 3 over 2 or 1.5. Therefore this one here becomes equal to 1.5 squared plus 1, that's root of 3.25, right? Great, so we have that. So then we expect to have a component from these are going to be components from AB. So this one is AB by 1.5 divided by root of 3.25, right? Then this one would be AB by 1 divided by root of 3.25, like so, right? So once we have that information, then we can apply the equations of equilibrium. Let's start with summation of forces in the Y, like so. So what do we have in the Y direction? Okay, we have a minus AB, right? AB 1 over root of 3.25 plus 4P divided by 3 equal to 0. Okay, then therefore AB is going to be equal to, what is AB going to, is going to be equal to 4 root of 3.25 P divided by 3. Okay, is that fine? Then we had assumed AB to be in compression, therefore since it has come out positive, it's in compression. Then we have summation of forces in the X direction, like so. So what do we have? We have AF minus AB by 1.5 divided by root of 3.25 equal to 0. Right. We've already calculated what AB is, so just replace AB there. And when we've done so, you're going to realize that AF is equal to the roots, they cancel, 1.5 there cancel, therefore this gives us a 2P, which is assumed in that same direction in tension. Right, so let me write down these results on the body here. So here we have a 4 3.25, okay, P outside divided by 3, okay, And then AF, what do we have? We have 2P, and this in tension. This one is in compression. Right? Let's pick joint. Let's pick joint E. All right. So there we go. I think I'll pick it from there like so. So we have there the applied load. The reaction force 4P over 3. We have another reaction there which is a P. Then let's assume both of them are in tension. The equations of equilibrium will give us the correct direction. We don't have to worry. As long as we've done the correct thing during working out the equations of equilibrium, everything should be fine. Then we have the slopes here. These slopes are similar. The slope here is equal to the slope there. Okay, so I'll just show for one. So this one, it will be something like this. All right. Okay, so what we have? We have at the very bottom for ED, we have 0.5. We said D equal to 1. Then there we have 1. And then the hypotenuse, we have 0.5 squared plus 1 squared. So we have root of 1.25. Okay, it's the same with the other one. So let's draw up the components. We're going to have one component there, which is ED by 1 divided by root of 1.25. Okay, and then in the same direction, we are going to have a component from EF, which is going to be EF by 1 divided by 1.25. And then EF is going to have another component in this direction, which is EF by 1 divided by root of 1.25. And then we'll have another component from ED, which is ED by, okay, this one is not 1, it is 0.5. Sorry, EF, it is 0.5, not 1. Okay, and ED also is going to be 0.5 divided by root of 1.25. Right. So these equations are enough. Let's apply the equations of equilibrium. Summation of forces in the y equal to 0. What do we have? In the y, let's say we have a minus 4p over 3. Okay, plus EF 1 root 1.25 plus ED 0.5 root 1.25 equal to 0. And then since this equation has two unknowns, we'll need another one with the same unknown so that we solve them simultaneously. So let's work out another equation. Summation of forces in the x direction. So we have a positive P, and then we have a minus EF by 0.5. Sorry. Here it is ED 1 over that. All right. So EF root of 1.25. Then we have a positive ED, which is 0.5 divided by root of 1.25 equal to 0. Okay, so there we go. So let's solve this simultaneously. So what I'll do is I'll multiply them by 2 and then sum them up. Okay, so this is a substitution method, right? So the top is going to give me minus 4p over 3 plus 2p, and then we have the other second one, it will be plus 0. Then the third one, it will be plus 2ed divided by root of 1.25. is equal to 0. Okay, then we can work out this one here. This one here becomes minus 4p plus 6p over 3. Okay, 2ed divided by root 1.25 equal to 0. So if you work out this, it gives us a 2p divided by 3 plus 2ed divided by root of 1.25 equal to 0. So 2 and 2 goes. Therefore, our ed is going to be equal to minus root of 1.25p divided by 3. And since we had assumed it to be in tension, ed is in compression. So let me just indicate it. ed is therefore root of 1.25 divided by 3. Okay, now let's calculate what EF is. So we are using this equation. So we have a P minus EF 0.5 divided by root of 1.25 plus ED by 0.5 divided by root of 1.25 is equal to 0. Okay, so let's replace our ED here. We replace our ED there. Okay, we replace our ED there like so. And then if we did so, we'll have the following expression. We are going to have the following expression. P minus EF 0.5 divided by root of 1.25 plus ED is a minus, so this is minus root of 1.25 divided by 3 p, then 0.5 root of 1.25 equal to 0. Right, this and this goes, then here is 1, then here 0.5 into 3, how many times does it go? It is 6 times, right? Here it is 6, right? Okay, so what we have finally a P minus P over 6. Okay, then minus EF 0.5 divided by root of 1.25 equal to 0. Okay, so this therefore gives us P minus C just as good as P, 6P divided by P minus P over 6, EF 0.5 divided by root of 1.25 equal to 0. And this therefore gives us EF is going to be equal to, we have a 5P there, so we have 5 root of 1.25 p divided by 6 times 0.5, which finally gives us divided by 3. Okay, so this is the final solution for EF. So EF is 5 root of 1.25 divided by 3p, and is in tension. So we have joint D. Joint D, what do we have? Joint D, there we go. So the joint D, we have this compression, which is a root of 1.25 P divided by 3. Then let's assume here tension, which is dF, and then let's assume here compression, which is dB. These slopes are the same. Okay, these slopes are the same. These slopes are the same. So this is 0.5, this is 1, and this is 1.25. Okay, so let's write down the components. We are going to have one component there and another one there from dB. So this one is dB, 1 divided by root of 1.25. This is dB 0.5 divided by root of 1.25. And then we'll have another one in this direction like so. And then we'll have another one like so. So this one is okay, there's already a force there. Sorry, it's already okay. Of course it will have non-forces. So this one is root of 1.25 P divided by 3 by 0.5 divided by root of 1.25. So this one therefore gives us this and this goes, this and this is P over 6. Is that so? Then this one is root of 1.25 P divided by 3, then by 1 over root of 1.25. This and this goes, therefore we have a P over 3. So we have these forces. Quickly, let's apply the equations of equilibrium. Summation of forces. Alright, summation of forces in the y direction equal to 0. What do we have in the y? We have P over 3. What else? Minus dB 1 over root 1.25 equal to 0. Therefore, our dB will be directly equal to root of 1.25 P divided by 3. And this one is in compression, right? Okay. So summation of forces in the x direction equal to 0. So we have P over 6, and then we have a plus dB 0.5 divided by root of 1.25. Okay, and then we have minus dF equal to 0. That not so. Okay, so if we replace dB here, we are going to have P over 6 plus P over 6 minus dF equal to 0, and therefore our dF is going to be equal to 2P over 6, which is basically just a P over 3, and this is in tension. So dF is P over 3 and is in tension, and then dB is root of 1.25 divided by 3 P, and this in compression. Okay, so dB is root of 1.25 divided by 3 P, and this in compression. Joint F. There we go. So joint F, there we go. We have 5 root of 1.25 P divided by 3. And then we have a tension force there in dF, which is a P over 3. And then let's assume this one is in tension, the one we want to find, which is FB. Okay, and that slope, we already know it. That slope is, that slope is 0.51, then root of 1.25. And then what else do we have? We have another tension force this side, which is a 2P. Right. So we expect to have a component here. We expect to have a component there like so, and another one like so. So this one is FB, 0.5 divided by root of 1.25. Then FB, 1 divided by root of 1.25, like so. And of course, you expect another component there like that, and there like that from the other side. So this one is just 1.25 divided by 3P times 1 divided by root of 1.25. So therefore this just gives us a 5P over 3. And then this one also, we have a 5 root of 1.25 divided by 3P by 0.5 divided by root of 1.25. So this one basically gives us a 5P divided by 6, right? So quickly, let's apply the equations of equilibrium. Summation of forces in the, we can start with the y is equal to 0, so that we find our unknown. So what we have FB positive 1 divided by root of 1.25, then minus 5P over 3, right? And therefore FB is going to be equal to 5 root of 1.25P divided by 3, and is in tension. Okay, so let's apply another equation to just prove the x-axis if everything is fine. Summation of forces in the x direction equal to 0. We have a minus 2P. We have a minus 2P. We minus 2P, then plus P over 3. Then we have a plus 5P over 6. Then we have a plus FB 0.5 divided by root of 1.25 equal to 0. So let's look at this one. A minus 2P, this one we can convert it to becoming we can make it become a minus 6, minus, we want to add it together. So this one can be equal to a minus 12P divided by 6 plus 2P divided by 6 plus 5p divided by 6 plus, since we already know what FB is, we calculated FB, we say it is 5 root of 1.25 over 3. So when it comes into here, root cancels out, 0.5 goes into there, therefore remain with a 5. This becomes a 5p divided by 6 equal to 0. So for sure this meets our criteria, and therefore this one here is equal to what did we find is 5p root of 1.25 divided by 3p, and is in tension, and this one is in tension for all the members. So we have member AB is equal to 4 root of 2.25 divided by 3p, and is in compression. And then member AF is going to be equal to 2p, and this one is in tension. And member BF or FB, doesn't matter, is equal to 5 root of 1.25 divided by 3p, is in tension. And then member FD is equal to p over 3 and is in tension. And member FE is equal to 5 root of 1.25 p divided by 3. And member DE is equal to root of 1.25 divided by 3p, and this one is compression. FE is in tension. And we have BD, which is equal to root of 1.25 divided by 3p, and this one is in compression. And then we have member BC, this one is just going to be equal to 0, and DC is equal to 0. Right, I think basically that's about it. This is the summary of the solution for all the members, and I hope the video was helpful. If it was, give me a thumbs up. Bye bye, and see you in my next screencast.